Hi, welcome to Technical and Engineering Academy. This is Blessed Elvis. Okay, so today let's do the exactness of the differential equations. So exactness of differential equations are equations of the form where we have, let's say, m, y comma x comma y rather, of dx plus n, x comma y dy. So these equations that we have above are what determines the exactness of an equation. So whenever you have an expression with respect to gx, that function is for m. And whenever you have an expression with respect to gy, then that function is for n. Now, when we are testing for exactness, we must differentiate the given expressions. So when we are differentiating the function that is here for m, we always differentiate the function for m with respect to y. So whenever you are differentiating whatever values you are given, you only differentiate the part which has y. You ignore the part for x. And likewise, for differentiating n, you always differentiate n with respect to x. So you always keep y constant for this part. So you only differentiate the values that have the coefficient of x. That's how it goes about this. So whenever after you have differentiated the given expressions, and then you find that the function, or rather the differentiation for m, is equal to the differentiation for n, then that function is said to be exact. So when they give you the same values for differentiation of m and differentiation of n, then that function is an exact differential equation. So always whenever you are given expressions, you look for the functions which has dx. So the function that has dx is the function for m. Then the function that has dy is the function for n. After you have discovered that, you always first have to differentiate the function for m with respect to dy. With respect to y. Like I have said earlier on, I'm just doing the summary so that we can easily understand. So even for n, you always differentiate the function for n with respect to x. So make sure that you understand this. So let's look at examples. Okay, so test for exactness the differential equations. So we have been given the first equation here and the second equation. So make sure that you take note of these equations so that when we answer them, you are going to have a clear picture. So make sure that you take note of these equations so that you will be referring to them as we are answering in the equation. So we have been given the function, and in the function that has dx, that's our function for m. So in this case, our function for m is given as, according to the expression that we have just seen, is given as sine of xy plus 1. Then we also have they have added x, y, cos of xy plus 1 here. Okay, so we have this. So in this case, we have to differentiate this function with respect to y. So only the y part is what we will differentiate. So when we differentiate sine, we know we are going to have cos, and when we differentiate y, we are only going to have x here. So this x will multiply it throughout. So here we are going to have x, then here this will change to cos. So we write whatever is in the brackets here. That's according to the differentiation rule of the trigonometric functions. Then we come to this part. So this part here, we have two functions. We have a function for y and the function for the cos. So we have to differentiate the cos first, the y, and then we differentiate the cos second according to product rule. So when we differentiate y here, we are just going to remain with x, since differentiation of y is just 1. So we have this cos of xy plus 1. Okay, so remember we are differentiating this according to product rule. So after we have differentiated with y, we also have to differentiate with cos. So differentiation of cos is the negative of sine, and then differentiation of the y here, as we have done before, we are just going to have x. So this x multiplied by this x, we are going to have x squared. So in this case, we are going to remain with x negative of when we multiply this x with the x that is remaining here in the brackets, we are going to have x squared. Remember, this time we are keeping y, so we are going to have here, this will change to sine. Of course, we are going to have xy plus 1 in the brackets. So now when you look at this expression and this expression are the same. So in this case, we are going to add these two expressions. So let's just create space by removing this top part here, since we don't need it anymore. Okay, so when we add this and this, of course we are going to have the derivative of m with respect to y equals to, when we add these two, we are going to have 2x cos of xy plus 1. Then here we have negative minus x squared y sine of xy plus 1. Okay, let's just create space here so that we are not confused with this. Okay, so I'm sure you are following up what we are doing here, and make sure that you are taking notes somewhere so that you don't stay confused. Okay, so here we cross these brackets. Remember, this side we have minus x squared y, then here we have sine of x y plus 1. So this is our differentiated expression for m. So let's also differentiate n with respect to x. So this time we are just going to deal with x, but the function of n the function of n has been given as x squared cos of x y then plus 1, okay, with respect to dy. So in this case, we are going to differentiate this with respect to x. So we are going to differentiate partial derivative of n with respect to x is equals to, so even here, remember we have the product. So since we have the product here, when we differentiate this x squared, we are going to have 2x. Then this is just going to come the way it is, xy plus 1. Then when we differentiate cos, we are going to have negative. Okay, so negative of sine. Then when we differentiate in this bracket x, we are going to just remain with the y. So when we multiply y with the function that is here, that is x squared, we are going to have x squared y. Then this cos will change into sine, so we are going to have sine of xy plus 1. Okay, this let me just rub. Okay, let me not rub. Let me just create some space. We do not stay confused. Okay, so in this case, we are going to have y here, and then sine of xy plus 1. Now, if you look at this differentiated equation for this function and the differentiated equation for this differentiation are the same. So this implies that the function for m and n are equal, since we have the function of this, the function of with respect to y, and also the differentiation of n with respect to x. Since we have them the same, this implies that the given expression is exact. So let's look at another example. So now, according to the question, we have been given that m of x comma y equals to, we have been given is 2x plus sine y dx. Okay, so in this case, we are going to differentiate partial derivative of m with respect to y. Now, this function has x, so we are not going to consider it. We just have to ignore it. So we will differentiate this one which has y. Since here we are differentiating the function of m with respect to y. So even this one will be differentiated with respect to y. So the differentiation of sine y, of course, is just positive cos y. So we are done. Now, if we look at the function for n also, make sure that you keep that in mind. Let's just keep that somewhere so that we are reminded of what we have already done. So we have had the differentiation of this as that. Let's keep that. So we have the function for n. Function for n is given as 2x cos y. Okay, let's just for the sake of space, let's just delete this. So make sure that you take note of it somewhere so that when we get back to it, you will still not get confused. Okay, so cos y plus y. Okay, they have given this with respect to dy. So in this case, we have to differentiate n with respect to x. So only the part that has x is what we will differentiate. Okay, so when we differentiate 2x here, what are we going to have? Of course, we are just going to have, or rather there was no, let's just delete this. There was no, I've just realized that there was no y. There was no y there, so we just had the function of n having x comma y equals to 2x. There was no y here, it's just 2x cos y, and then here we had y. Okay, so let's differentiate this. So we have the differential of n with respect to x. So here we are just going to differentiate the part that has x. So now the part that has x is this part here. So when we differentiate to x, we are just going to have 2. Then this will just come out the way it is. Now this part we will not consider it because it's y and we are differentiating with respect to x. So we are just going to differentiate this. So if you remember, we had that the differentiation of m was cos of y. So this and this of course are different. Since we are different, this we have 2 here, and here this one we don't have n constant value as 2 here. So these are different. Hence we have shown that the function for n is not equal to the function for m. So in this case, this implies that the given function for m is not equal to the given function for n. So this is not exact. Okay, so this is the basic introduction to exactness. So make sure that you understand this concept, because whatever we are going to be doing will be based from the same concept. So make sure that you fully understand this concept. If at all, repeat as much as you can so that you have the concept, because whatever we are going to dive in will be based on the same. So let's look at another example. Okay, so we have been asked to solve the given expression that is here. So make sure that you write this equation so that whatever we are going to do, you will be referring to the same. Now, according to the question, this time we have been asked to solve the given exact function. Now, how are we going to know that that's exact? So according to the question, we have been given that m we have been given that m equals to 5 x raised to power 4, then plus 3x squared y squared, then subtracted by x y power 3. So in this function, as we have been doing, we have to differentiate the function of m with respect to y. So we are just going to differentiate the part that has y. Now this part doesn't have y, so we will just ignore it. So when we differentiate y squared, we are going to have y squared. So when we differentiate y squared, sorry, I made a mistake. When we differentiate y squared, of course we are going to multiply this 2 here with the 3 that is here, which of course we are going to have 6x squared. Now according to power rule, after we multiply with the base, we subtract the power. So when we subtract 1 from the power 2, we are going to remain with 1, which of course is just going to be y. Then we also differentiate this. Where there is y here, we take this 2 to multiply with 2, so that we have 6 here. So we have 6x. Then when we subtract 1 from the power, we are going to have 2. So we are going to remain with y squared. So make sure that you keep this so that we come to relate whenever we find the differentiation for n. So this is how we have differentiated this. So let's also differentiate for n. Remember, we have been asked to solve this. So let's keep this. Now the function for n has been given us. The function for n has been given as 2x raised to power 3 minus 3. Oh, sorry, for this one there is y. So we have y minus 3x squared y squared, then subtracted by 5y raised to power 4. So let's differentiate this with respect to x. So here, when we differentiate x raised to power 3, of course this power will multiply with 2. We are going to have 6x. Then we subtract 1 from the 3 power of x. We are going to have squared here. Y will be constant since we are just differentiating with respect to x. Then minus, when we differentiate x squared, of course this 2 will multiply with the 3 there. We are going to have 6. Then x. When we differentiate this, we are going to subtract 1 from the power according to power rule. So we are just going to have x, and then here we have y squared. Now when we look at the function for m and the function for n, these are the same. Remember, m, after we had differentiated m with respect to y, we had 6x squared y minus 6x y squared. So of course this and this are the same. So we have proven that this is an exact. So what's the next point apart from this? So since we have proven that this is an exact, the next point you should do when you have been asked to solve the exactness of an equation, what you have to do is you have to integrate, okay, to find the function. You have to integrate the function of m given with respect to what? Dx. So in this case, remember, we have been given that our m was 5x power 4. Let me just write this properly for the sake of, so 5x power 4. Then here we have positive x squared y squared, then minus 2x y power 3. We are integrating this with respect to x. Okay, so in this case then we are going to integrate this part using dx. Since there is dx here, so this implies that we are integrating this with respect to dx. Remember, when you are integrating the function of m, you integrate it with respect to x, but when you are differentiating, you differentiate with respect to y. So in this case, when we are integrating, we are going to integrate with respect to x and then keep the y constant. So y we will not consider it. Okay, so when we differentiate this part here, we are going to have 5x, and again, according to power rule, you add the power with 1. Of course, 4 plus 1, we are going to have 5. Then you divide by the same power, which is 5. Okay, and then plus here. So even here you do likewise. So we are going to have 3x. You add 1 to the power. Of course, here we are going to have 3. And then you divide the same power, that is 3. Y will just come out the way it is. Y is just kept constant. Then here minus, you also add 1 to the power. So here we have 2. So you add 1 to the power. Here power doesn't have any power, so which implies that there is just 1. So 1 plus 1 is just 2. So we have 2 here. Then we divide by the same power. And then here we have y power 3. Okay, plus the constant c. Now in some books, they write the constant in different ways. Some books they will use y, they will use f of y, some they will use x, they will use any other letters that they feel like. So in this case, then we are going to cancel 5 here, even here we are going to cancel 3, even here we are going to cancel 2. So remember, what we are remaining with here is, after we have manipulated this, we are just going to remain with the function of f of x comma y. We are going to remain with only x power 5. Then here we are just going to remain with x power 3. We have already moved the denominators. We have already cancelled out what is the same on the numerator and the denominator. So here we are just going to have this, then plus the constant c. Okay, now after you have had this, the next step you have to do is to differentiate this same expression with respect to n. After you differentiate with respect to y, after you differentiate, you equate it to the function of n, then you are done. So in this case, we are going to differentiate the function of m. We are going to differentiate this. We are going to differentiate this function, okay, of x comma y with respect to what? To y. Okay, and then equate it to the function of n, the original function of n, not the one that we had differentiated. Okay, so in this case, let's do that. So firstly, let's differentiate. Oh, so remember we have the function of x comma y. We have the function of x comma y equals to x power 5, then plus x raised to power 3, y squared minus x squared, y power 3 plus constant c. So this is the function that we had. I'm just writing this. So let's first differentiate this. So we are differentiating the function of f with respect to y. If you want, you can just use m here. If you be confused, you can even use m. Remember what we have been doing with this? It's just the same thing. So when we integrate, when we integrated, we had this x power 3, then x squared, y 3, then constant c. So let's differentiate this with respect to y. Now when we differentiate this one here, what are we going to have? We are just going to have 2 x power 3. Remember, we also subtract 1 from the power, so we have this. Then minus, when we differentiate this with respect to y, we are just going to drop this 3 here. X is just kept constant. Then when we subtract 1 from the power, we are going to have this. Then plus the constant c, which we are differentiating. So we are just going to write c prime for the sake of differentiation rules. Okay, so we have this here. Now this is what we are going to equate to the function of n. According to the rules, we said that after you have differentiated, you also equate it to the function of n. Okay, so let's do that. So remember, after we have differentiated, we have 2x cubed y minus 3x squared then y squared, okay, and then plus c prime. So this we are going to equate to the function of n. The original function of n was 2x power 3 y, then minus 3x squared y squared, then minus 5y power 4. Okay, power 4. Sorry, let me just write that properly. So we are going to have minus 5y power 4. Okay, you just bear with me. Just know that this is 5y power 4. Okay, so make sure that you do that. So as we can see, this and this will cancel, this and this will cancel. So here we are just going to remain with y, x, or c rather, c prime equals to, we are going to remain with what is here, that is negative 5y power 4. So this is the differentiated expression. Now remember, in the expression, after we had integrated the value of m, after we had integrated it, we had where we had the constant c. So this is what we are really looking for. Now in the given expression that we have attained this far, how can we have the c constant? The only way we can have that is by integrating this expression. So we have to integrate this expression and also this expression. So after we integrate c prime, we are going to have c equals to, after we integrate this, we are going to have negative 5y. When we add 1 to the power, we are going to have 5 divided by the same power, we have 5. So this and this will cancel. So this implies that our c now equals to negative y power 5. So this is our value of the constant c. Now remember the function that we had after we had differentiated the function of m. After we had integrated the function of m, we had x power 5 plus x power 3 y squared minus x squared y power 3 minus y power 5 plus c. But c, we have found that c equals to negative y power 5. So let's replace that. So in this case then, we are going to have m, or rather, instead of writing m, let's write f of x comma y. Since this is a general equation, even here we have to remove m. We have to write f, since we are finding the general concept, the general equation. So in this case then, we are going to have x raised to power 5 plus x raised to power 3 y squared minus x squared y power 3 minus y power 5, and then minus, where there is c, we add negative y power 5. So we have here negative y power 5. So this is our differentiated, or rather our solved equation when it comes to exactness. So make sure that you understand the concepts. So the idea behind this is that firstly, you have to determine the exactness of the given functions. Secondly, you have to integrate the function of the given m. Third, you have to differentiate that function for m after you have integrated it. Then you differentiate it. After you differentiate, you equate it to the function of n. After you equate it to the function of n, you compare what are the same, you cancel out. What are the same, you cancel out. Then you remain with a certain function, with a differentiated function of c prime. When you have a certain function of c prime, then you differentiate the given expression, whatever you have here. You integrate. After you integrate, you are going to have c. So c, you will be equated to certain values here. So these values are the ones that you are going to replace in the integrated function of m that you had done at first. So I hope that you have gotten now the concept. That's all about this. Now if you want to prove that whatever you have done is the exact function, or if you want to get back to the question, firstly you have to differentiate the given expression with respect to, firstly, x, secondly, you differentiate with respect to y. When you differentiate the two expressions, you are going to get back to the question. So I hope that this video has given you a clear insight of how to go about the exactness of the functions. See you in the next video. Thanks once again, guys, for staying this far. Please like, subscribe, share, and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.